Have you ever wondered how computers make decisions? What if I told you it all comes down to a simple yes or no? Welcome to the captivating world of Boolean logic, a brainchild of the 19th century mathematician and logician, George Boole. This formal system is the beating heart of digital logic and modern electronic circuits. At its core, Boolean logic is binary, dealing with true and false values. These are represented by 1 and 0 respectively. It's like the computer's own language, a binary conversation of ones and zeros, of trues and falses. It's a simple yet powerful logic system that forms the foundation for how our digital devices process information, make decisions, and ultimately function. So in essence, the logic that powers our digital world boils down to simple binary decisions. Now, you might be wondering, how does a computer use these yes or no values to make complex decisions? It's all in the operators. Let's dive into the heart of Boolean logic, the Boolean operators. They are the key to how computers make decisions. These operators are and, or, and not. The and operator is like a strict gatekeeper. It only allows a true or yes result if both conditions it checks are true. Think of it like needing both a key and a password to open a vault. If you have both, the vault opens. That's a true. If even one of them is missing, sorry, but the vault stays closed, that's a false. Next up is the OR operator. It's more lenient than our AND gatekeeper. It requires only one of its conditions to be true to give a true result. Picture it like a party invitation that says you can bring a guest or a dish. You don't need both to get in, just one or the other will do. Lastly, we have the NOT operator, the contrarian of the bunch. It simply reverses the value it's given. If it's handed a true, it flips it to a false. If it's given a false, it turns it into a true. Imagine it like a mirror. It gives you the opposite of what you show it. When we combine these operators, we can create complex logical expressions. It's like crafting intricate sentences using only 3 simple words. This is how computers can make sophisticated decisions using only yes or no values. Take a moment to marvel at the simplicity and elegance of Boolean logic. With just 3 operators, we can create a language for computers that can express complex ideas and make intricate decisions. With these operators, we can start to build complex logical expressions. Remember, these are the building blocks of digital decision-making, and they're at the heart of how our modern world operates. With a grasp of Boolean values and operators, we can now explore how they power our digital world. The heart of every computer, smartphone, or any digital device is a microprocessor, a complex arrangement of millions, sometimes billions of transistors. These transistors, acting as tiny electronic switches, form logical circuits, which are the building blocks of our digital systems. They process binary information, the ones and zeros, based on the principles of Boolean logic. Consider a basic logic gate, such as an AND gate. It has 2 inputs and 1 output. The output is true, or 1 if and only if both inputs are true, or 1. This simple gate, in large numbers and combinations, forms the basis of complex logical circuits. These circuits, in turn, enable a microprocessor to perform all its functions, from mathematical calculations to decision-making processes. Let's zoom out from the hardware and look at the software side of things. Algorithms and flow control structures in programming languages are often based on logical evaluations that follow the principles of Boolean logic. For instance, a simple if-else statement in a programming language is a direct application of Boolean logic. Imagine you're writing a program for an automated thermostat. You might write a statement like, if the temperature is below 68 degrees, then turn on the heat, else turn off the heat. Here, the if is checking a Boolean condition. Is the temperature below 68 degrees? The answer is either true or false, and the action taken depends on this Boolean value. Boolean logic also plays a crucial role in database queries and search algorithms. When you type a query into a search engine, you're often using Boolean operators without realizing it. For example, if you search for cats and dogs, the search engine will return results that contain both terms. If you search for cats or dogs, it will return results that contain either term. These search algorithms are based on Boolean logic. The influence of Boolean logic extends even to graphic design and digital art. In vector graphics software, Boolean operations are used to shape paths. For instance, you can use the union operation to combine 2 shapes into one, or the difference operation to subtract one shape from another. These operations are essentially the same as the OR and NOT operations in Boolean logic. It's clear that Boolean logic is at the core of our digital world. From the microprocessors in our devices to the software we interact with daily, Boolean logic is at work, turning a world of ones and zeros into a rich tapestry of digital experiences. From your computer's processor to the code running your favorite apps, Boolean logic is hard at work. But the influence of Boolean logic isn't confined to our digital devices. It permeates deeper, into the realm of mathematics and computer science, in ways that might surprise you. Let's take a deep dive into how Boolean logic shapes our world beyond gadgets and gizmos. One of the most profound influences of Boolean logic is in set theory. Set theory, at its core, is the study of collections of objects, which we call sets. Boolean logic provides a framework for understanding the relationships between these sets. The AND operator, for example, is akin to the intersection of two sets, where we look for common elements. The OR operator, on the other hand, is like the union of two sets, combining all unique elements from both. The NOT operator represents the complement of a set, containing everything that the original set does not. In this way, Boolean logic provides the foundation for understanding and manipulating sets. In the realm of mathematics, Boolean algebra stands as a testament to the influence of Boolean logic. Boolean algebra is an algebraic structure that captures the essence of logical operations. It provides a mathematical representation of the basic principles of logic that are so integral to the digital world. But let's not forget about the practical applications. Boolean logic is the cornerstone of integrated circuit design. Logic gates, the building blocks of digital circuits, are physical manifestations of Boolean operations. They are the ones that make our computers, smartphones, and other digital devices tick. Beyond hardware, Boolean logic also plays a critical role in software. Search algorithms, for instance, heavily rely on Boolean operations to sift through vast amounts of data and retrieve relevant information. Similarly, decision-making in automated systems is often based on Boolean logic. Whether it's a self-driving car deciding when to brake, or an AI chatbot determining the best response, Boolean logic is at the heart of it all. Boolean logic, indeed, is the invisible force driving the logic of our digital world. It's everywhere around us, underpinning the technologies that shape our lives and the mathematical principles that govern our understanding of the world. So, why does Boolean logic matter in our modern world, you may ask? Well, it's quite simple. Boolean logic is the bedrock upon which we build and understand our digital world. It's the language that computers and electronic devices speak, the grammar that guides their operation. Think about it. Every time you use a computer, a smartphone, or even a simple calculator, you're interacting with systems built on the principles of Boolean logic. It's the system that underpins the digital logic and modern electronic circuits that make these devices possible. But the significance of Boolean logic doesn't stop there. It's not just about the gadgets in your hand or on your desk. It's also about the invisible processes that keep the digital world spinning. Consider computer programming, for instance. Algorithms and flow control structures, those complex systems that tell a computer program how to behave, are often built on logical evaluations that follow Boolean principles. When programmers craft these algorithms, they're using the same and, or, and not operations that George Boole defined way back in the 19th century. And let's not forget about set theory and Boolean algebra. These mathematical disciplines, which are crucial in fields like computer science and electronic engineering, are also deeply rooted in Boolean logic. Now think about the intricate web of integrated circuits within your computer, or the sophisticated search algorithms that power your favorite search engine. All of these are grounded in Boolean logic, but perhaps the most crucial role of Boolean logic lies in its contribution to decision-making in automated systems. From self-driving cars to automated manufacturing processes, Boolean logic is the silent conductor orchestrating the symphony of automation that is becoming an increasingly prominent part of our lives. So, to answer the question, Boolean logic matters because it's the foundation of our digital world. It's the simple yet powerful language that allows us to create, understand, and interact with the amazing digital systems that enrich our lives every day. In the end, Boolean logic is a simple yet powerful tool, the backbone of digital logical reasoning and an essential part of our digital lives.